Greetings, friend, and welcome. Farms are beginning to use drones, sensors, cameras, autonomous tractors, machine vision, crop models, and robotic equipment to monitor fields, detect weeds, identify crop disease, spray chemicals, predict yields, and reduce labor. The field is becoming a data environment, and the machine is starting to see the crop before the farmer does. The basic idea is precision agriculture. Treat each section of a field differently instead of treating the whole field as one flat surface. GPS, drones, sensors, and AI systems can measure crop health, soil conditions, moisture, pests, disease, and plant growth. The goal is to apply water, fertilizer, pesticides, and herbicides only where they are needed. One 2025 review said precision agriculture using GPS, drones, and IoT can improve yields by 20 to 30% and cut input waste by 40 to 60%. Agricultural drones can fly over fields with cameras and sensors, then use AI to read what the human eye may miss from the ground. They can monitor crop health, detect pest infestations, inspect soil conditions, support irrigation decisions, and help predict yield. A field problem that used to require walking rows, checking leaves, and guessing at scale can now be turned into maps, alerts, and treatment zones. AI is being trained to detect crop disease from images of leaves, plant color, canopy patterns, and field conditions. Instead of waiting for visible damage to spread across a field, the system can flag early signs of disease and mark where the infection may be starting. In one recent example from India, researchers developed an AI-powered flying robot for sugarcane fields that captures close-up leaf images, detects diseases such as red rot, smut, wilt, and ratoon stunting, and uses GPS tagging to identify infected plants. John Deere acquired Blue River Technology for $305 million to bring computer vision and machine learning into farm equipment. CNH acquired Raven Industries in a deal valued at about $2.1 billion to expand precision agriculture and automated farm technology. These companies are not just selling tractors anymore. They are building machines that collect data, analyze crops, automate work, and turn farming into a platform. With Blue River, Deere built See and Spray, a system that uses computer vision and machine learning to make plant-level decisions, distinguish crops from weeds. Instead of spraying an entire field evenly, the machine can identify plants in real time and spray only where it sees weeds. Research on AI-driven variable rate sprayers shows systems that can detect weed presence, estimate canopy size, and activate nozzles in real time. John Deere has been pushing autonomous tractors and other driverless agricultural equipment as a response to farm labor shortages. Newer autonomous tractor systems use cameras and onboard computing to process field conditions in real time. Deere has also shown autonomous equipment for orchards, where labor-heavy jobs like spraying pesticides and nutrients can be difficult to staff. When drones monitor the field, AI detects disease, cameras find weeds, autonomous tractors move through rows, and sprayers decide where chemicals go, the human role changes. The farmer becomes less like the person physically working the field and more like the operator of a machine system built around food production. The pitch is efficiency and sustainability. Less chemical waste, better crop health, lower labor pressure, more precise irrigation, and higher yields from the same land. A system that sprays only weeds instead of the whole field can reduce chemical use. A drone that finds disease early can prevent wider crop loss. But the same tools also move more control into equipment companies, software systems, farm data platforms, and the companies that own the machines. Once the farm is covered by drones, sensors, autonomous vehicles, cameras, and cloud-connected equipment, the crop is no longer just a crop. It becomes data: soil data, seed data, yield data, chemical data, disease data, machine data, weather data, and labor data. Whoever controls the platform can see the farm at a level no single farmer ever could. When food production depends on machines, software, cloud platforms, and corporate equipment systems, who really controls the farm? You're watching the Singularity Hub. Subscribe for more and stay ahead of the weeds.